Kia ora, y'all. This is a great turnout. Please don't tell the fire marshal. Right, that wasn't too bad. Let's see how well we do. Right, so my name is Phoenix. I'm a senior blockchain developer here at Centrality. At Centrality, we are one of the world's leading blockchain venture studios. We are building, among other things, a decentralized marketplace for blockchain applications. In short, we're going to be to blockchain what AWS is to cloud computing. But enough of that, let's get to why we're all here. So, nanobots on the blockchain, an introduction to smart contracts. I'm actually going to start this off in a slightly unconventional way. I'd like to introduce you all to my imaginary friend. So everyone meet Lana. I said friend, not girlfriend. This is totally normal and healthy. So Lana lives in a world, perhaps not too different from our own, where smart contracts are a part of everyday life. And by the looks of things, so is reading, thank goodness. So we're going to follow Lana on a typical morning and just see kind of what life would look like if smart contracts were more integrated into daily life. So Lana's alarm goes off at 5:58 a.m. Her smartwatch was monitoring her vitals and the quality of her sleep during the night, and it instructed her alarm clock with the optimum wake-up time. When Lana wakes up, she receives a quantity of incentive tokens in exchange for sending the data automatically to her doctor. Lana then wakes up, she gets dressed, brushes her teeth, does a bunch of other things we haven't figured out how to automate quite yet. And she makes herself a cup of coffee and she books a ride to the gym. So she pulls out her smartphone, she opens up the smart contract powered Uber application, and she enters the destination, the gym. Her phone picks up the location where she's currently at. She enters the maximum amount that she wants to pay for her fare, and she presses the book button. Immediately, an invisible bidding war breaks out among all the self-driving vehicles in the area, all of whom are independent economic actors, each of which has a cryptocurrency wallet. The winning vehicle is selected based on considerations like price, proximity, reputation, and so on, and it immediately plots a course to Lana's home. While Lana is waiting, she pulls up a tablet and she starts streaming some content. After 4 minutes, the car arrives, she shuts it off. Her wallet pays for exactly 4 minutes of content, 10% of which goes to the mesh network where all the files are hosted, and the other 90% goes straight to the content creator. Lana gets to the gym, she finds an unoccupied locker, she scans the QR code with her phone. Her wallet automatically pays the daily gym membership fee, making sure to spend the incentive tokens from her doctor first, and then the lock on the locker unlocks. She has a productive workout, and afterward, when she's relaxing in the locker room, she remembers that she has an upcoming trip to Madrid and she hasn't booked her accommodations yet. So she pulls out her smartphone, she opens up the Airbnb smart contract powered application, goes through the listings, finds one that she likes, and she books it. Now this apartment has a smart lock on the door. So during the period of her booking, all Lana has to do is approach the door, or more precisely her smartphone has to approach the door, and it will unlock automatically for her. So I think we'll leave Lana for the moment, mostly because this is starting to feel a little stalkery. But I think that this gives you kind of an idea of the potential that smart contracts have to transform our lives. So, what are smart contracts? See, I put glasses on it. It's how you know it's smart. Works in the movies. Anyway, so what are they? Well, we don't really have a formal definition just yet, but here's a good model for thinking about it. The humble vending machine. Maybe not what you were expecting. So when we get right down to it though, what is a contract really but just an agreement between two or more parties? And that's kind of what we have here, right? If the customer inserts the required amount and denomination and type of currency, then the corresponding product is released. That's a contract. It's just not written on a piece of paper, it's written on a circuit board. Now incidentally, this model of the vending machine was proposed by a computer scientist by the name of Nick Szabo in 1994. For comparison, Bitcoin was invented in 2009. So 15 years before blockchain was a thing, we had smart contracts. Problem is though, vending machines don't scale very well. So we're going to focus on, in a decentralized ledger or in a blockchain context, what is a smart contract? A smart contract is an autonomous software application that lives on a decentralized ledger and can participate in transactions on the ledger. So it's autonomous. That means that once you launch it, you relinquish control over it, which is actually very important, as we'll see later. It lives on a decentralized ledger. In the case of, say, Ethereum, that means that the source code is literally stored on the ledger itself. But more generally, it just means that every participant in the node can run the code. and it can participate in transactions on that ledger. So in order to interact with the smart contract, people actually publish transactions to the blockchain that interact with that smart contract. And depending upon the platform, the smart contract itself could issue transactions to other people or even to other smart contracts. Some names that you might have heard for smart contract are a decentralized application or a DApp, DApp. I'm not sure. The D's got a line through it. I'm not really sure how to pronounce that. Also decentralized autonomous corporation or a DAC. Slightly older decentralized autonomous organization or a DAO. Not the DAO, but a DAO. Right, cool. So why are we doing this? What's the point? So one of the first things that smart contracts brings to the table is interoperability. Smart contracts are designed to work together and almost automatically. It's really, really cool. When you deploy a smart contract to a decentralized ledger, you basically get an entire web service layer for free. Also, smart contracts can share data in an automatic but managed way, so data silos are going to be a thing of the past. Of particular interest is democratization. So the interaction between customers and the smart contract is going to change relative to how we do it today between consumers and businesses. In particular, once self-sovereign ID becomes a thing, consumers are going to have an unprecedented level of control and ownership over their own data. Additionally, the interactions between value creators and platforms is going to change. So platforms you think of like your Ubers of the world, Airbnbs, Patreons, and so on, and the value creators then for Uber, those would be the drivers, for Airbnb, the property owners, and so on. Sometimes there can be a bit of an antagonistic relationship between the two, or sometimes it feels like maybe the incentives of the two groups are not really aligned. However, with smart contracts, we now have a ton of new options for making sure that those things are aligned. So for example, value creators can participate in governance, or the smart contract could pay value creators in tokens issued by the smart contract. Think of it kind of like paying contractors in shares of company stock. So there's going to be a whole lot of new opportunities for us to kind of get those incentives aligned together and really have people working together to solve real problems. And transparency. So if every single participant on the network can see the code and they can see the data, boy, that gives everybody a very clear window into exactly what's going on. And when you have an agreement between two or more parties, that is absolutely what you want. Because everything is written in computer code, it is virtually impossible for people to disagree. At least for humans to disagree. Sometimes humans and computers don't see eye to eye, but we'll get to that. And oh yes, there's more. So efficiency. At last count, the Ethereum network had, I think, about 30,000 nodes, give or take a few. So that's 30,000 independent devices, virtual machines, computers that are running the code. Anyone want to hazard a guess what it would cost to spin up 30,000 EC2 instances and 30,000 RDS databases on AWS? I think the monthly cost alone would bankrupt 90% of all businesses. With a network like Ethereum, you get that for free-ish. We'll get to the ish part later. And you get it regardless of whether you're a one-person startup or a multinational conglomerate. And 30,000 nodes also means 30,000 backup copies of your data. It's a pretty good number. That's the kind of number where if you lose all your backups, it's probably because something happened to the planet. But there's another side to this coin that we have to talk about. So the first one is smart contracts are software, and that means we do have to talk about bugs. And these are not your garden variety bugs. Sorry for the pun. Think a computer program that's hooked up to your bank account. This is a contract where if somebody finds and exploits a vulnerability or a loophole, they can do it thousands of times per second until your bank account is totally dry. So actually, we're going to make this actual scale. It looks more like this. That's better. Now, that said, this is not a new problem. The guys that programmed the Mars lander, they understand you only get one shot. The guys that work for large financial institutions, they understand the consequences of you introduce a bug, your customers or your clients lose millions of dollars. So it just means that testing becomes really, really important. So you want to deploy your smart contract to test nets before you deploy it to the real thing. You may even want to run your own test nets. Think about things like a bug bounty program, and code audits become absolutely essential. Next on our delightful journey, permanence. So one of the fun things about decentralized ledgers is, let's just say it's really, really hard to change stuff, especially anything that's already happened. So when you deploy a cloud-based application, we kind of take things like software updates for granted. But using Ethereum again as an example, if you change the code for a smart contract, you've actually just created a brand new smart contract with its own address. Meanwhile, the old one is still there on the blockchain doing its thing. And smart contracts don't come with a built-in kill switch. So if you didn't think to program one in, or worse yet, if there's a bug in the kill switch that you implemented, then it's still there processing transactions. If it's got a bug or a security vulnerability, then it's hemorrhaging funds until the day is over. Now again, this is not really a serious problem. It's one that we know about, and I think it will go away in the future. But in the meantime, it's something you have to think about. So for example, in Ethereum, a workaround is a technique known as delegation, where you have the old smart contract sort of forward all of its transactions to the new one, and thereby you've effectively implemented a software update. But again, you don't get it for free. It's just something you have to think about. And transparency is great, except when it's not. So it's great when your customers and your partners can audit the code and the data, maybe not so great when your competitors and hackers can do the same thing. Now, depending on the context, this is actually quite mitigatable. So the first thing to consider is you're not going to take your entire business and put it into a smart contract. Realistically, you're going to find aspects of your business that fit that model, and you're going to deploy those, and everything else you're going to keep more or less the same. Also, you have the option of what's known as a private or permissioned blockchain, or a private or permissioned ledger, where only trusted parties can get access. So you can still be open and transparent, just with a group of trusted parties. And we're having so much fun, let's keep going. So because blockchain, we have to talk about some overhead. How many of you guys are familiar with the concept of block times? Okay, good, it's about half and half. All right, so then I'll explain. A block times basically refers to the average amount of time it takes before a transaction is confirmed by the network. Until that transaction is confirmed, it could be countermanded, it could be dropped, it could just go out into the ether and disappear. So it's not considered final until it's included in a block. Now on Ethereum, the average block time is about 15 seconds. In EOS, which is a smart contract platform that's due to launch, I think later this year, maybe early next year, I believe they're targeting 3 seconds. And just for fun, for comparison, the Bitcoin block time is 10 minutes. And you're recommended to wait for 6 confirmations before you consider a transaction final. So that's, you open up your Uber application, you put in your details, and you press the big green button, and 1 hour later, your driver's dispatched. Not very tenable. The good news is, though, this is not really a problem for your smart contract. This is more a UX problem, say, for your mobile app, right? So your team's going to have to decide whether every action is represented as confirmed, even though there's a chance it might disappear, or you kind of implement some kind of a pending state. And depending on your application, one or the other might be more appropriate. The other thing about overhead is transaction fees. So if you're out on a public ledger, to incentivize the miners and the computers that are going to run your code, you have to pay some kind of a fee. And that fee is denominated in the token native to that currency. So if you deploy a smart contract on Ethereum, your customers are going to have to pay that transaction fee in ethers. But your customers don't have ethers, they have NZ dollars. And the last thing you want to do is call up your customers and say, great, now, could you just wire your money to this cryptocurrency exchange in China, and then go over here and place this order? Yeah, it's not going to work. Now, the good news is, again, we have ways around this. We have what are called gateways. Gateways are payment processors. They accept credit card payments, FPOS payments in NZ dollars, and then they will credit the customer's wallet with the corresponding amount of tokens. So this is not really a huge problem, again, for your smart contract. It's just something that you'll need to abstract away for your customers. And finally, we can't talk about anything blockchain without talking about this guy. So blockchain's totally unregulated. That's by design. I'm going to talk about this from 2 aspects. So the first one is there's no central authority on the blockchain. If some guy comes along, finds a weakness in your smart contract, exploits it, steals $100 million worth of ether, on-chain, there's nothing you can do about it. There's some things you can do off-chain, send Big Lenny 2 thumbs, find the guy, break his kneecaps, or whatever, get the authorities involved, whatever. Anyway, but on-chain, there's literally nothing you can do. So again, you just have to make sure you get it right from the beginning. You don't get a lot of second chances. The other thing is that regulators haven't quite made up their minds what to do about smart contracts yet. And it's kind of a hard problem. I mean, how on earth do you regulate an autonomous software application that is executed simultaneously on 30,000 different computers in 200 jurisdictions? I don't know the answer. I don't think anyone does. I'm not even sure if there is an answer. But until we get some guidance, it's kind of a minefield. I suspect we will start getting some really solid guidance from regulators probably later this year. But until then, it's just sort of tread carefully and consider it sort of an experimental platform, at least from a legal perspective. So I'm going to assume that you weren't dissuaded by the last couple of slides. Let's talk a little bit about implementation. So you're excited about this, you want to do smart contracts. How do you decide if it's the right fit? So I'm going to break this down into, I think there's a bunch of questions you need to ask yourself, but there's 4 in particular that I think are a really good litmus test for will this work or won't it? So the first question is, do you need collaboration between multiple parties? So just like you wouldn't need a legal contract to get 2 departments in the same company to cooperate, at least I hope not. If you do, tell me your stock ticker because I know who I'm shorting next. But in the same way, you don't need smart contracts for a purely internal process. Second question to ask is, are your business processes purely digital? So the interesting thing about smart contracts is all they can really do is twiddle some bits on a decentralized ledger. That's really it. They can interact with other smart contracts, but all those smart contracts can do is change some records in a distributed database. Now, in some cases, that's actually fine. So as an example, if you have a ticketing service like Event Finder, right? Companies can publish venues and events onto the ledger through transactions. Customers can then purchase their admission through the same mechanism. All you need at the event is a tablet that's connected to the internet, scans a QR code, checks for a corresponding record on the blockchain, lets them in. Easy enough. For a lot of use cases though, you probably won't be able to do this 100% digitally, so you'll need a kind of a hybrid approach, which I'll explain in a second. Next question, can you store your data in a distributed ledger? So every participant in the blockchain can see the data. If you're relying on personal or protected, proprietary, I guess anything starting with P, any kind of data, this may not be the right fit for your smart contract, or at least you're going to have to get a little bit creative about how you store or access the data. And then finally, are you willing to publish your source code? So same idea, any participant can see the source code. So if your applications rely on, say, proprietary or complex mathematical models, you might not want to put that into a smart contract. I mean, obviously you don't want to publish the recipe to your secret sauce, but also if people can see the models that are determining things like, say, credit scores, that gives people an opportunity to start analyzing the algorithms and look for ways to game the system. Now, you don't have to answer an unqualified yes to all 4 of these questions to do smart contracts. It's just that the part of your business that is going to go into a smart contract, you do have to be able to answer yes for all of these. So as an example, let's take an insurance policy, which, by the way, I do think we're going to see smart contract insurance policies. If we haven't already, we're going to see them very soon because they are very, very, very good for this. So you have a smart contract, it lays out things like the policy limits, the excess amount, all the different conditions. That part's easy. But what happens when the policyholder makes a claim? Someone's got to actually go out there, verify that it's a legitimate claim, and assess the damages, right? And let's be honest, AI ain't that good yet. So this would be a case where you can implement most of this as a smart contract, but you need to come up with a hybrid approach where basically the assessors are able to go out and do their thing and then inject that information into the blockchain so that the smart contract can then continue and pay out. I don't know the lyrics, so I can't sing along. Right, okay, let's go a little bit deeper. Don't worry, I'm not going to descend into computer code here. But let's talk a little more about implementation. So, you found your killer use case, you've been able to say, yes, this is going to work, we can do this, it's totally feasible. Great, what next? So for the most part, implementing a smart contract is really not that different from implementing any other kind of product. You're still going to get a lot of the same people involved, so senior leadership has to get involved, you may have to get board approval, legal has to get into it, you're going to need product managers. All of that, none of that really changes. The difference is there's a couple of extra questions you have to ask and a couple of additional people you have to get involved. So the first question that you need to ask when you're designing your smart contracts is actually not a question, sorry. It's kind of an imperative. Upskill your team and or bring in experts. So as we saw with the Sky Tower sized bug, you don't get a lot of second chances in a decentralized ledger. You have to make sure you get this right from the beginning. And there's a lot of pitfalls. There's actually entire libraries now that have been written just to address all the potential security vulnerabilities that can affect your smart contract. So find the firms that can help, either upskill your team or just bring them in to help you design it. This is going to be very, very important. Okay, first question that's really a question. Should you use a public or a private ledger? This is a bit closer to implementation than strategy, but I put it up here because it's really important. It's pretty much going to decide everything else about how you implement your smart contract. So if it's public, like customer facing, then you also need to figure out which technology you're going to use. Will you use Ethereum, EOS, and so on? Or if it's private, maybe for governing the interactions between your company and a vendor, or to create an industry consortium, then you're probably looking for private, maybe Plug, get the plug, or Corda, Hyperledger, what have you. And this is important because each of these platforms has its own capabilities and limitations, which will then inform the capabilities and limitations, or if we're being honest, even the feasibility of your smart contract. Next one, how will it connect to the real world? So again, smart contracts can only twiddle bits on the blockchain. So if we need input, say from trusted parties or oracles, or if we need outputs, either web service calls or Internet of Things integration, these are things you're going to have to think about. What regulations will it need to comply with? My favorite topic. So is the smart contract going to be qualified, or better yet, will it cause your company to be qualified as a financial services provider? What KYC or AML requirements are you going to have to comply with? What happens if someone's able to trick the smart contract into doing something illegal? Or my favorite one, what happens if a customer asks you to delete their data under the EU right to be forgotten laws, which on most blockchains is actually technically impossible? I don't know the answer to that one. It'd be fun to see what people come up with. Who will write the code? So for a customer-facing smart contract, this one's pretty straightforward, right? But what about for something that's going to govern interactions with, say, industry peers or with vendors, right? Think about a legal contract. If you have, you want to collaborate with a bunch of different companies, you're not going to have one company write the contract and everyone else just has to go along with it. You're going to have a collaborative process where everybody gets involved. And you're going to have to do the same thing if you're building smart contracts. And just as important, who will audit the code? So in addition to writing the code, you also need somebody who's going to compare the outcome to the contract, which in this case actually serves as the requirements document. You take a legal contract and you check to see if the smart contract matches up. You also need someone who's going to analyze the code, look for security vulnerabilities, make sure that the code is operating efficiently, it's not costing you too much gas, for example. So I think we're actually going to see a new industry emerge here, which is at the intersection of software engineering and legal. And these sort of crypto law firms, as they're called, are going to offer these kinds of services. And also, how will it make money? So for public-facing smart contracts, is it going to issue its own tokens that customers will have to buy? Is it going to take a cut of every sale? Kind of an important one. Maybe it belongs at the top, I don't know. All right, with that, I'm going to switch over now to my favorite part of the presentation. This is the part where if I got anything wrong, there's no negative consequences. So I've got a couple of lists over here. The one on the left is my thoughts as to which companies or industries are going to be most impacted by smart contracts this year. And then on the right, I've added some that I think will, as soon as some companion technologies come along, we'll see smart contracts impact them in a very big way. Some of my favorites here, so peer-to-peer, anything with an order book, any platform that matches up buyers and sellers, that is eminently convertible into a smart contract. So be on the lookout for those. Financial systems, again, the same idea. I think just the other day, Swift actually announced that they did their proof of concept with a decentralized ledger, and they said it went very well. So expect at some point in the future, overseas transfers will go from taking 3.5 weeks to 3.5 seconds. Over on the right, one of my favorites, 3D printing plus Internet of Things with self-driving vehicles. So let's take Amazon.com and put that into a smart contract. You browse the catalog, you find a product that you like, you make the purchase, and that immediately causes some 3D printer somewhere in the world. It immediately turns on, it produces the product, and then just like how Lana had that invisible bidding war to get the self-driving vehicle to drive her to the gym, a similar thing could happen to find the drone that ultimately carries that manufactured product to your door. With mesh networks, we're going to see some major disruption, especially in the telcos and the ISP space. So imagine this could be what a cell tower looks like in the future. Instead of routing your calls through centralized towers, you actually route your call through all the different mobile devices in between you and the person you're calling. How are you going to pay for that, though, for using someone else's bandwidth? You can't do that with a centralized system. There's just too much activity, and the payments are tiny, tiny, tiny. Something like smart contracts could make that happen.